Exercise 4.3, problem 11 to 15 solution. So if matrix A equal to 1 minus 2 minus 3 4 and A plus B is 0 matrix or null matrix, then B is okay. So we know when a matrix to A plus B is 0 matrix, then B will be equal to minus A, right? Basically it will be an additive inverse, right? So basically, so B will be equal to, you'll have to multiply each and every element of A with minus 1. So it will become minus 1. Minus into minus, this will become 2, and this will become 3, and this will become minus 4. Each and every element of this must be multiplied by minus 1. So this is our B. And which option is this? Minus 1, 3, minus 4. That is option B. Okay. If you want, you can quickly check this. If you add this and this, you'll get 0 matrix, null matrix. 1 minus 1, 0. Minus 2 plus 2, 0. Minus 3 plus 3, 0. 4 minus 4 is 0. So that is why, so this is nothing but B is an additive inverse of BA. So it's basically you're multiplying each and every element of A with minus 1. So option B is our answer. Okay, you got to be very careful in selecting these options because you see very small change. There's it looks very similar, so you got to be carefully analyzing before selecting the correct option. Right, next problem 12. So if matrix A equal to 4 minus 2 6 minus 3, then A square is, they have given various options. So basically A square is A into A. So 4 minus 2, this A by A, and 2 by 2. So the resultant matrix will be also 2 by 2. So this element is first row, first column. So first row to be multiplied with first column. So that is 4 4s are 16 minus 2 into 6. You need to add it up. And this is first row, second column. So first row of this matrix multiplied with this second column. Multiply it, you'll get this. Then this is first row, second column. Sorry, second row, first column. Second row, first column. Multiply this. 6 4s are 24. Minus 3 into 6 is minus 18. Then this is second row, second column. So second row of the first matrix, second column of the second matrix. So 6 into minus 2, minus 3 into minus 3. Simplify this, is 4 4s are 16, and this is minus 12. So 16 minus 12 is 4. Right? This is 4 into minus 2 is minus 8, and this is minus 2 into minus 3, that is minus 6. Plus 6 will become plus, right? So minus 8 plus 6 is minus 2. This is 6 4s are 24, and this is minus 18. So 24 minus 18 is 6, and this is 6 into minus 2, that is minus 12, and this is minus 3 into minus 3 is 9. So minus 12 plus 9 is minus 3. So you got this final matrix. So you can check this one out. So this is between these and 2. Okay, 4 minus 2, 6 and minus 3. So option D is our answer. Okay. Next, problem 13. If A is of the order m by n and B is the order of p by q, then addition of A by B is possible only. Addition of the matrices is possible only with similar order, or the order must be same. So m must be equal to p and n will be equal to q. So that is basically option D. Right? Otherwise, see, addition, what does addition of matrix mean? You are adding all the corresponding elements. So when can you add corresponding elements? Both the matrices must be of the same order, right? What is order here? M by n in the first case and p by q. So both the orders must be equal. So m must be equal to p and n must be equal to q. Okay? Right. But for multiplication, we know differently, right? So if it is multiplication, the number of columns of the first matrix must be equal to number of rows in the second matrix. So that is different. So problem 14. Here, see, they have defined the matrix multiplication and they are asking us to find the value of A. So this matrix is multiplied by this to get you this, and we are asked to find the value of A. So all we need to do is do the matrix multiplication. Okay. So this is 2 by 2 and this is 2 by 1. So the resultant matrix will be 2 by 1. 2 rows and first 1 column, right? So that is what it is. So first row into first column. So A into A2, 2A, 3 into minus 1, 2A minus 3, and 1 into 2 and 2 into minus 1. So 2 minus 2, that is basically 0. But anyway, equate this with the right hand side, which is 5 by 0. So these two matrices are equal. Okay, which means the corresponding elements will be equal. So 2a minus 3 will be equal to 5, or 2a will be equal to 8, or a will be equal to 4, right? So a equal to 4 is option B. Am I right? So this is one element. This is actually 2 by 1. Okay, please don't confuse it with 2 by 2. This is 2 by 1 matrix. Maybe I should have added one more step. Okay, so 2a minus 1 is one element. 2 minus 2, that is basically 0. Okay, and that's what you can say, 0 equal to 0, and this will be equal to this. Okay, so now let's get to the 15th problem. Okay, if if A, matrix A is such that A square is equal to identity matrix, we'll have to prove this equation, which one is true, right? So basically let's do the matrix multiplication. So alpha beta gamma minus alpha equal to alpha beta into gamma minus alpha equal to identity matrix. Identity matrix is 1 0 0 1. Only the diagonals will be having elements. All other diagonal elements will have non-zero element. That is basically it will have 1, and all other elements will be 0. Okay, so that's our identity matrix, because the resultant matrix, see, this is 2 by 2 and this is 2 by 2. So the resultant matrix also will be 2 by 2. So that is why I am writing identity matrix of the order 2 by 2. This is all implicitly told in the problem. Right, now 2 by 2. So this is first row, first column, right? So first row of the first matrix multiplied with the first column. So alpha into alpha square and beta gamma. Similarly, this is first row, second column. So first row of the first matrix multiplied with the second column. So alpha into beta beta into minus alpha is minus beta alpha. So this is first row, second column. Sorry, second row, first column. So second row of the first matrix multiplied with this first column. So gamma into alpha, and minus alpha into gamma is minus alpha gamma. I think it's a mistake here. Okay, so this basically, let me correct that actually. So this is minus alpha, this is second row, first column, right? So second row, so this into this, so gamma into alpha is gamma alpha, minus alpha into gamma, so this is minus alpha. Okay, right, next one will be, this is second row, second column. So second row is this, and second column, so gamma beta minus and minus, so this is minus alpha into minus alpha will become plus, right, equal to the unit identity matrix or null matrix, unity matrix, right? So each element will be equal, but if you look at it, so this is alpha square plus beta gamma will be equal to 1, or if you simplify this, this will be 1 minus alpha square minus beta y will be equal to 0, and that is 1 minus alpha square minus beta square, option C. Am I right? And see, these two you don't need to use because this is equal to 0. So alpha beta minus beta alpha will be equal to 0, or alpha beta will be equal to alpha beta. That is known, right? So, but whereas when you equate this also, you will get the same, right? This is equal to this. So if equating this, what will happen? You will get alpha square plus beta gamma will be equal to 1. You are getting the same equation, right? So 1 minus alpha square minus, transfer this to the right hand side. So it will become 1 minus alpha square minus beta y equal to beta gamma will be equal to 0. Okay, it's an interesting problem. But only thing is that 1 mark for this is little too low. Okay, thanks for watching this video.